So as you can see, I work for Lockheed Martin, and some of you are already familiar with, but Lockheed Martin is a huge company. We have over 100,000 employees around the world. So I'm just one engineer, my own personal opinions as well as experience with the company and other places. But we're involved in things from air, land, and sea and outer space. So all over the place. I happen to work in software most of the time. I would say I have multiple jobs. My title is systems engineer. I actually also do training. I do STEM outreach and user research and design. So that's one of the fun things you'll hear me say is I love variety. And I think a lot of us, right? Our job has variety in it. It's not like we do one thing all the time. So first of all, what is systems engineering? I know it sounds like a really vague title. So hopefully I can help clarify that. And then some examples or specifics such as the life cycle. And then as teachers, I want to give you resources. And I think that's important. So with that, let me keep going and thank you for your input. So, and bonus if we have time for cyber, but I know we'll probably run out of time. So first question is, right? Teachers, you know so much and you keep up on, a whole year's worth of material. So who knows what world-changing satellite system was first launched in 1978, right? And if you ask your students, they'll probably think, wow, that was a long time ago. So anybody out there have an idea? Right, we think, oh, we're in advanced technology nowadays. We're launching satellites and we have SpaceX and we have this and we have that. Well, we've been launching satellites for a long time, right? The answer is GPS. So GPS is actually the first software system I worked on at Lockheed Martin. It was cool. I didn't even know how neat it was at the time because I started at Lockheed over 20 years ago, and we didn't have GPS in our cars. We didn't have GPS on our cell phones. We really reserved the use of our cell phones then to emergencies versus using them all day long. So I was working on, so when you look at GPS, probably one of the first things you thought of was you use GPS. You have an app on your phone and people are always looking at your location. So you and I are users. So there are different groups of people or different segments, and we're part of that user segment. And then in the picture, you can see the satellite, right? So that's the space segment. And my boss actually worked on GPS-3 satellites, which are what's currently being launched these days. And then there's also the software, the control segment. So there are a group of people who control the satellites that are orbiting around the Earth. So it takes, a group of satellites working together to provide our GPS. And so for US teachers, my tip is go to this website. It's fantastic in terms of, it doesn't always have high fidelity graphics. However, it does have that poster that you asked me for, which says, how does GPS work? And then it also has lessons that you can use and some basic explanatory information. And in terms of, I worked on the ground control segment or the operational control, like you think of a command room. There's a little video from an operator talking about that. So, a wealth of information, and I think people are working really hard to put resources out there for you. So what is systems engineering, right? Now, when you first look at this slide, my guess is your reaction is, I don't feel like reading all that text. And the light bulb catches your eye. So the big picture is systems engineering is about those big picture ideas and breaking it down and organizing it and that detailed coordination, right? So if we look at a standard definition of what is system engineering, it comes from INCOSE. It's the International Council of System Engineering. And it's an interdisciplinary approach to realize successful systems. So when we do engineering, you've probably taught that you need to understand, a problem, there's a problem to be solved. So we want to understand customer needs. And when we understand those needs, we're going to look at what's required, what's the required functionality of the system. And we need to write that down. And so that's what I was looking to see, your friends in English who maybe they don't have the fun hands-on labs, but English is important in that we need to communicate. So what I tell students is, if you wanted to build the F-35, is there anybody here who can build it by themselves? No, right? So it takes a team and it takes communication. Or if you have an idea that you want to build the next great thing, you're probably going to convince somebody to give you money to go build that. And so you're going to need to communicate those ideas. And with requirements, we write down our understanding of what the customer needs. And then we share that with them and we go back and forth to make sure that we understand what it is we're trying to build. And then we go forward then with design, and we then might hand it off to people who build it. And then we come back with testing to make sure, you have a couple types of validation I'll talk about. But systems engineering is pretty broad. And even with that, you can have specialties like in certain domains. So I hope that helps a lot. And the tip I'll give there to pass on to your students is, if you're interested in something like systems engineering, or even human factors like usability, look for organizations out there that do that, because you might have never thought of it before, but there are groups of grown-ups who get together and share their common interests as well as standards. And so like there's a standard definition for systems engineering, there are standards out there that people follow, and it makes work easier, as well as volunteer for a conference. If you volunteer, you could get in for free instead of thinking, I don't have the money to pay the registration fee. And not only that, but then you can meet people and network. And certainly if you're a person who's interested in a field and you ask others about it, they're probably happy to share what they know and help you get connected. So systems engineering, from even just trying to use an analogy, if you look at Lockheed Martin, I said we have over 100,000 employees. Well, part of systems engineering is breaking things down and organizing them. And I think, we teach young people from, elementary school how to organize and how to look for patterns. And so, we take our business and we organize it into different areas. And I'm in rotary and mission systems. And even with that, we have great breadth in that I'm in software, cyber and intelligence, and we also have Sikorsky helicopters. And so we have a lot of different things that we work on, but we try and find ways to organize that. And then we break it down to smaller pieces that people can actually work on. When we're talking about systems engineering, this is very common. So like one of the fundamental lessons is the V, right? Systems engineering V. And I'm really zoomed in. So I'm going to use software as an example. And like we talked about at the beginning on the top left, you want to look at the system definition. What is it that I'm trying to accomplish? And sometimes we might call that the ConOps, the concept of operations, the operational concept, same idea, right? So there are some people who come out with the big ideas, and then people even look at the architecture and high-level design, maybe which computer systems, hardware, and things I need to use. So design decompetition, again, is that organizing and breaking things down. And then if we're talking about software, right, we'd go from high-level design to low-level design. And so me as a software systems engineer, I would tend to work this, and maybe I start with a high-level design and I include software developers, and then I hand off to software developers, and I still would be joined with them, but then we might work the design to lower level details together. And so we have a transition where they then take the leadership and ownership, and they build something. And when they build something, they should test it, right? They should test their own work, check your own work, do your own proofreading. So even though they think they have it perfect, there's also an element of hardware that maybe is going along with that as well. But you put those together and then they pass it off to another group. And hopefully you want independent testers, right? Because just like you read your own paper 100 times, you then can't see the bugs or you don't think about it differently. So it's good to hand it off to a different group that would do the testing to either take the individual pieces and put them together. We call that integration. Because sometimes, we try and put this piece of software on this computer and it doesn't work, but it works on the other computer. You know how that works. Certain things don't work together. So we need to integrate the pieces and make sure they work well together and test it. And then we build it up. It depends on how big your system is until you get to the high level. And you make sure that you verify the system. So some people distinguish the difference between building what I intended to build and building what the customer asked for. And so both of those things you need to do. So you build it back up and see that you have the final system. So this V I'm showing, right? I'm showing you development and then manufacturing, deployment, and training. So when we test and build and test a system, eventually, right, we're going to give it to somebody. So we might call that deployment. And it depends on how big your system is and what you're working on, that certainly one person could do many jobs, or people can just do one piece of this. So you can have an architect, you can have a systems engineer, you can have a software developer, you can have a tester. Like, test is actually a fun job. Like, I like to tell people that's a fun place to start. In terms of other people build the software, they give it to you and you get to play with the app or play with the software, and your job is to break it. Somebody's going to pay you to break it. How much fun is that? And then you don't even have to fix it. You just give it back to them and they have to fix it. And then they give it back to you and you test it again. And so you're really doing a favor and a service to the customer, because we want to give them a good product when we're done. And I guess that's a good thing that students sometimes, and grown-ups too, right? Sometimes people get upset when they don't get it right the first time. And part of engineering that we want to emphasize is it's an iterative process, that we don't expect things to be done exactly right to perfection the first time, because even when you build something well, there's usually room for improvement. And so again, people who think they do a great job, they need to be able to accept constructive criticism, to know that I can make this better, and to listen to other people's feedback. So there are a lot of personal skills that are important. And if you notice, this is a similar picture, but it's a lot simpler. So if I go up, you see it's fancy and then it's plain. So sometimes we make those fancy pictures, and sometimes we need to get rid of all the extra noise, I'll call it. And so one of the things we learn to do is, when is it appropriate? And I hope that you can encourage students as well. And then, remember I said I was zooming in on software? So if you zoom out, look at the path across the top of my slide, right? Development is only one piece of it. And if we were to build something bigger, we might have manufacturing, deployment, training, operations, maintenance, refinement. And you hate to think of it, but after you build something, there will come a day when you retire it, that something new comes along. And so even students who might be good at training and might be good at explaining things to other people, maybe they enjoy technical things, training is real. We have some really high-tech training with simulations and so on. So engineering has a lot of variety in it, and I was just zooming in on this one piece here. So what's it look like in the day of life of an engineer? And so I really like to dispel the myths of everyone's introverts and we sit at desks all day. So we have these great big ideas, or I talked about breaking things down to smaller levels that we can assign to individual people or teams to work on. I talked about how we have to write down and define the requirements. And I talked about that testing at the end, where you need to make sure that you built what you were supposed to and that it works. And so that checklist kind of reminds me of rubrics that you give students. So one challenge, I think that's a good example, and it depends where you are and what type of assignment you have to give. But think about, are there any cases where I can have the student make up the rubric? Because that's what we do, is we make up the requirements and then we have to deliver to them. And so I think that's an interesting twist when people are used to being given the rules and how do I get an A and what do I have to do? Sometimes you have to figure it out for yourself what needs to be done. All right. So as I mentioned, working with people is a big deal. Communication skills are important. And again, we have plenty of introverts. I'm not saying everybody has to get up and give presentations, but we do need to be able to communicate. And I do find it very embarrassing if there's an adult who has poor grammar, or if we're going to argue about how a sentence is written. And I'm going to give you another example coming up. So what makes a good systems engineer? Good communicator, and I don't want to overstate that, it's just part of life, but customer focused. For me, I like to make things better for other people, and just being customer focused, that's who we're trying to serve. And as I mentioned, I love variety. So technical depth and breadth is one of the benefits of working in system engineering. One of the things I was told early on was to think of a triangle, and that when you start out your career, you want to get as much breadth as possible and try different things and explore. That's what I'm trying to encourage young people. And then over time, you can specialize and narrow things down. But breadth and depth is one of the things that we go for. And then the big picture, the big ideas, the big picture, and being able to put it together, because you want to look at the different components and organize that and make sure that one passes or feeds into another. Strong teaming skills, being flexible, willingness to learn, because right, if you're always working on new projects or building something that hasn't been built before, there's obviously a lot to learn. So don't be afraid to ask dumb questions. I know my team lead, he invites me to meetings because I'm good at asking questions. So that's my reputation, is asking questions. And I know sometimes there are students who they might feel bad or that they look bad because they're asking lots of questions. And asking questions is actually very important. So what is a requirement, right? I mentioned your rubric. So when you're a system engineer, sometimes I said you have to write out requirements. And that's important because in our world, requirements actually become legally binding statements. And wow, so I don't know that people think, oh, I want to be an engineer and write legal documents. So not necessarily a legal document and the way people think of it traditionally, but we have lots of statements that say, I will build this, I will build that. And so we want to, again, be able to write well. And if you see the last part there being italicized, right, we're going to refine it through customer interaction, research, and trade studies. Now, here are a couple of examples that the such and such system shall do something. So traditionally, we would use the word shall a lot, and it might seem somewhat boring. But if I said the system shall perform in the air and perform underwater, or if I said the system shall perform in the air or underwater, those are two different things. And it could imply a big cost difference, whether I had to do them both or whether I could do one or the other. So sometimes, being careful and attention to details is important. The other thing that we like to distinguish is systems engineers, they define what needs to be built, and then the next group that follows on, supposing it's software developers, they get to decide how it's built. So we would define the ideas, the design, what needs to be done, and someone else will figure out and actually build it. Now, like I said, if you're on smaller teams, you might do everything, but this is just a breakdown. All right, so here's my favorite part in terms of the GUI design. One of the things I work on is designing the user interface for apps. And it really is a concerted effort to try and make things easy. So one of the related disciplines is psychology, believe it or not. I work with some people who have PhDs in psychology because it's about how do people think, what catches their attention. Just like, you know, the color red and a stop sign, right? Pre-attentiveness, things that you recognize before you really think about it, those things come into play. So that's really getting into the detail. But if I start at the beginning, right? Brainstorming with people, defining the concept of operations, and then organizing that. And I gave the example of like organizing the company or the 3 segments that we have with GPS. Then there are techniques, and some of them, again, involve writing, where we might write out scenarios of how does the system work, who uses it, and then we'll take that scenario and we'll pull out the nouns, and then we'll organize the nouns to figure out how do we organize things. So that's just one example, you know, maybe to give the English teachers an example. But card sorting is a technique. So you learn different techniques of how to organize information. And then sketching ideas. So I will actually use PowerPoint and draw lots of pictures of how I want things. And one of the examples is low fidelity or high fidelity. If you see my picture, right, this might be called a wireframe in terms of you just identify where certain elements go. You don't necessarily have to fill out all the data. And you'll identify the structure and navigation, those sorts of things. And you'll also check, do I have everything covered? Do I have all the functionality that I need? Because sometimes you might realize you forgot something, or you might have things added in there that you really don't need. So this is just to give you an example. Now, if I switch to resources, because I know I'm almost done my time, it went fast. Here are a lot of resources. So one of our executive vice presidents actually is from Baltimore, and she started at the bottom of the company, and she has a really inspiring story. Her name is Stephanie Hill. And if you're into TED Talks, that's something to encourage students, right? So encourage them to use their time, their school, the network, and all this online learning that maybe they're getting tired of. But it gives us resources like today that I can talk to you without having to travel to Virginia, right? So take advantage of the online resources. This TED Talk is very inspirational. And what I did was I turned it into a cartoon and used Ozobots. If you've heard of those, they're reasonably affordable, around $50 a piece. They're a little robot about the size of a ping pong ball. And there are different levels of programming, like just color, literally like with markers coloring. So that might be an introduction with middle school and even elementary school. And then you can use this same little robot to program, like drag and drop programming. So that's a great resource. And then, you know, Lockheed Martin, we have our own YouTube channel and Flickr when you need things, videos and pictures. Some other things I talk about is coding and artificial intelligence, machine learning. I found this first one here a great resource with activities for machine learning. We did one where you try and train Pac-Man to avoid a ghost. So I think that reaches kids and makes learning fun. And then there are some of these other organizations and activities at the high school level, and we're starting some at the middle school level, but we do some competitions where it will, you know, give kids a chance to interact with other people, having fun, doing things they like, Code Quest, Cyber Quest. And then we also provide internship opportunities for the kids who participate in that. So they still have to apply for it, but then they're part of a special small group. And so, you know, Cyber Quest is the next one coming up around January. Registration will probably open way before that, but it's going to be virtual and a great opportunity, and it will fill up fast. So see if you can monitor that if you're interested and sign up probably the first day it opens. Code Quest will probably be a little bit later, and that's just straight programming. And scholarships, we have both 4-year college and 2-year college and vocational scholarships. If you're interested in the kids, the things that I do, like designing the user interface, I think they'll love this title, Don't Make Me Think. It's one of the famous books in the industry by Steve Krug. It's a small book, so it's a quick, easy read to kind of give a high-level overview of usability and that user interface design. And as an example, here's a book that's one of my favorites, as well as websites for more information. And again, that standards that comes up to know that there are standards out there for how you should design and build things. In terms of coding, these are suggestions for getting things started. And some of them are repeats, but the one in the middle, right? Create your own network at home and install Linux on an old computer. Sometimes we think, oh, this computer's too slow or old. Take it off the grid, put Linux on it, and that's a great skill that not everybody has, and it'll be a discriminator for you. As well as some of these other tools. A Raspberry Pi is, an affordable computer, or even, I didn't have on here, Arduinos are even cheaper. So I think I need to wrap it up, but I will flip over to some of the resources online. Just want to show you real quick. I want to stop that share, and I want to share my webpage. I can't find it. I'm trying to, why I can't share the web pages. Here we go. All right, so I mentioned, hopefully you can see now, if you go to lockheedmartin.com, right, I recommend searching on STEM. And Osiris Rex, I actually got to meet one of the engineers at the USA Science and Engineering Festival. But if you search on STEM, you'll get a lot of things, sometimes nice stories, but STEM education comes up. So when you click on the STEM education, we have several things listed, like the scholarships. And so I already mentioned CodeQuest, CyberQuest, and we have the 2 different scholarships. For fun, maybe students want to try out this career predictor. It's kind of like a personality preferences, short little quiz. We have that there. And, all right. And lastly, I noticed you're in Virginia. So George Mason, they have some things for people who are interested in gaming, like summer camps. And then again, for you as a teacher, the Naval Academy, they do fantastic STEM workshops. So they have specific things for you either in the summer or during the year. So keep an eye on those things. And there's the GPS website. So I'm going to stop the share and give you a chance to ask questions. And thank you, Kim, for letting me talk a little extra.
No, thank you. And since you mentioned some of the programs that the Navy has for STEM and education, we have a really great connection down in Hampton Roads with like naval defense systems. Really good connections with both their, I think like a program director and their educational outreach coordinator. So if anyone here is interested in anything having to do with the Navy, my 2 contacts down in Hampton Roads are fabulous. They're very interested in helping out anyone. A couple of quick questions. A lot of ways actually you can get to systems engineering. I guess I don't know if you could speak to some of the various ways you can get there.
So honestly, in our industry, a lot of times it's broad in that we will bring in people who just have a STEM degree. So whether it's, a variety of engineering disciplines or computer science or math, because it's interesting, a lot of mathematicians wind up engineering. And so I find that very interesting and good. But you can do systems engineering. And even nowadays, I think people are asking about certifications. So I have a bachelor's degree in engineering science, so that was broad background. And then I have a master's in materials engineering, which is totally different. And then I have certifications in web design as well as usability, so user interface design. And really, one of the things we'd like to stress is that you want to keep learning because, 20 years ago or 20 years from now, things are not going to be the same. And I was just reading today about someone said, well, their knowledge and skills are only good for about 2 years. Now, we don't want to discourage them and say that, but just develop that keep learning mentality. And so that's one of the things I enjoy is that always learning.
There's another question. And I know you've actually previously answered this question, but systems engineering is a huge field. And I didn't know if you could speak to, sort of the similarities and differences between a very, sometimes categorized as the same, but sort of systems engineering and industrial engineering.
Oh, wow. Well, my reaction is that they are different. So for my broad background in engineering, so the one industrial engineering class that I explored was statistics. And so there are lots of different applications of statistics. There are lots of different applications for industrial engineering. There's even industrial hygienists now. But industrial engineering, I tend to think of as the manufacturing process and quality control along those lines versus the system engineering I was talking about was more on the development side. So really, you can apply yourself in many different areas, and even whether it's Department of Defense, biotechnology, healthcare, software, or building airplanes, there are lots of different ways you can apply it, but it's that logical process and putting things together. So like I said at the beginning, you can apply it to different domains.
Awesome. Another question, how does one become a tester?
So testing, sometimes you can actually get the title of a tester or a test engineer. And sometimes you're just titled a systems engineer and you get to test. And when I talk about it, you can test software, or I also tested materials. So, literally taking something and putting it in a machine and breaking it. That's fun, right? And you're breaking it just to measure how strong it is. So there's a lot to learn. But same thing, if you have an engineering degree like STEM, whether it's science, technology, engineering, math, that engineering and science really helps that you can apply to be a tester. Some of the skills, if we're talking about software, would be scripting. So, if you are able to get on a command line and run a script to test things, that's one type of testing. But you can even start at what we would call a functional level, where somebody gives you an app, they give you a list of requirements, like the user wants to do these things, and then you try and do it as if you're the user, and then you try and do odd things, like do things in a different order, or things that maybe aren't so straightforward, and you see where the bugs are and the glitches. But that's the main thing. You want to try and see that it's working properly. And then you want to try the error cases. So people who can think outside the box and think about what if I were trying to break it is a different way to look at it.
So thank you so much. Those are all the questions we have.